Time travel isn't just a fantasy reserved for blockbuster movies or the wildest dreams of science fiction. Out there, beyond the comforting pull of Earth's gravity, time itself starts to behave in ways that challenge everything we think we know. In the realm of space, time is not a rigid river flowing forward at the same pace for everyone. Instead, it bends, stretches, and sometimes twists into knots that defy our everyday experience. The universe is filled with phenomena that make time travel not only possible in theory, but in some cases, an everyday reality for those who venture beyond our planet. So let's journey through the cosmos and explore the top 10 mind-blowing facts about time travel in space. First, let's consider a phenomenon that's happening right now, high above our heads. Time moves differently in space. Picture astronauts floating aboard the International Space Station, gazing down at the spinning blue marble of Earth. Up there, they are not just further from the ground, they are living in a slightly different stream of time. According to Einstein's theory of relativity, the speed at which time passes is affected by both gravity and velocity. Because the space station orbits Earth at over 17,000 miles per hour and is farther from the planet's gravitational pull, astronauts experience time a bit more slowly than those of us on the ground. The difference is tiny, mere fractions of a second over months, but it's real and measurable. When astronauts return to Earth, they are, in a very literal sense, a few milliseconds younger than their twin counterparts who stayed behind. Gravity, too, has a profound effect on the passage of time. The stronger the gravitational field, the slower time ticks by. Imagine standing on the surface of a massive planet, or, even more dramatically, near a black hole. The gravitational forces there are so intense that they stretch and warp the very fabric of space-time. Near the event horizon of a black hole, time slows to a crawl. For someone hovering just outside that invisible boundary, a single minute might equate to years, centuries, or even millennia for someone farther away. This isn't just a theoretical curiosity. Astronomers and physicists have calculated these effects and even observed them in the universe. Gravity, it turns out, is not just a force that pulls objects together, it is a sculptor of time itself. But this isn't just the stuff of distant stars and cosmic phenomena. The reality of time travel is woven into the technology we use every day. Take GPS systems, for example. The satellites that help you navigate to your favorite restaurant or track your morning run are orbiting high above Earth, moving fast and experiencing weaker gravity than we do on the surface. Both of these factors, velocity and gravity, mean that the atomic clocks on board those satellites tick at a different rate than clocks on Earth. If these differences weren't constantly corrected for, your GPS location would drift by miles every day, making the system useless. The next time your phone gets you to your destination, remember, it's only possible because scientists account for the time-bending effects of relativity. Now, let's push the limits even further. What happens if you travel close to the speed of light? According to Einstein's special theory of relativity, as you approach light speed, time slows down dramatically for you compared to someone standing still. This is called time dilation. In theory, if you boarded a spaceship and accelerated to near light speed, you could journey thousands of years into Earth's future while only a few years passed for you. This isn't just a mathematical trick. Particles called muons, created high in Earth's atmosphere, travel toward the surface at speeds close to light. Their internal clocks run slower, allowing them to survive the journey when, according to their normal lifespan, they should have decayed long before reaching the ground. In the realm of high-speed travel, time itself becomes a pliable, almost magical dimension. But what if you could do more than just stretch time? What if you could fold it? Enter the fascinating concept of wormholes. Imagine the universe as a vast sheet of paper. If you fold that paper so two distant points touch, you could create a shortcut, a tunnel through space-time itself. These hypothetical passageways, predicted by Einstein's equations, are called wormholes. If they exist, and if they could be stabilized, they might allow not just rapid travel between distant parts of the universe, but also journeys through time. Some theories suggest that traveling through a wormhole could let you emerge in the past or future, making wormholes the ultimate cosmic time machines. For now, wormholes remain theoretical, but their tantalizing possibilities continue to inspire both scientists and storytellers. Black holes, those mysterious cosmic vacuum cleaners, have their own role to play in the story of time travel. They don't just trap light, they trap time itself. The closer you get to a black hole's event horizon, the slower time moves relative to the rest of the universe. If you could hover just outside this boundary, you would see the universe outside racing forward, while your own clock ticked ever more slowly. Cross the event horizon, and time, as far as the outside world is concerned, comes to a halt. This isn't just speculation. Astronomers have observed the effects of extreme gravity on time by watching the light from objects near black holes shift and stretch. In the presence of these cosmic giants, time becomes a plaything of gravity, warped and twisted in unimaginable ways. The famous twin paradox takes these ideas and brings them down to a human scale. Imagine two twins. One stays on Earth, while the other embarks on a journey through space at near-light speed. When the traveling twin returns, they will be younger than their sibling who stayed behind. This isn't just a thought experiment. It has been demonstrated with high-speed particles in laboratories and even with astronauts in space. The most famous real-world example comes from the Kelly twins, Scott and Mark. Scott spent nearly a year aboard the International Space Station, while Mark remained on Earth. When Scott returned, scientists measured tiny but real differences in their bodies and their biological clocks. The twin paradox isn't just a story, it's a fact of nature, proven by experiment and experience. But what about traveling backward in time? Here, the laws of physics become far less accommodating. While general relativity allows for solutions that might permit time loops, so-called closed time-like curves, no one has yet figured out how to build a machine that can safely send information or people into the past. The reason is simple. Backward time travel could create paradoxes. What happens if you meet your younger self? What if you change something that prevents your own birth? These paradoxes have fascinated philosophers and physicists for decades, but so far, nature seems to protect the past from meddling. Traveling into the future is possible. Indeed, it's happening all the time, but the door to the past remains firmly closed. Yet, some scientists have proposed exotic cosmic phenomena that might open that door, at least in theory. One such idea involves cosmic strings, ultra-thin, ultra-dense filaments left over from the earliest moments of the universe. These relics, if they exist, could warp space and time so dramatically that they create loops, allowing for closed paths through time. If two cosmic strings were to pass close by each other at high speed, the resulting distortion could, in theory, make time travel possible. But finding or creating such cosmic strings is beyond our current capabilities. For now, they remain a tantalizing possibility, a reminder that the universe is full of surprises waiting to be discovered. And now, for the most mind-bending fact of all, you are already a time traveler. Every second, as Earth spins on its axis, orbits the sun, and whirls through the galaxy, you are moving forward through time. In fact, all of us are traveling through time at the same basic rate, about 1 second per second. The journey is relentless, unstoppable, and universal. While we may not be able to leap centuries in the blink of an eye or visit the age of the dinosaurs, we are all passengers on the greatest time machine ever built, the universe itself. Time is the most mysterious force in the cosmos. It shapes our lives, our memories, and our destinies. It can be stretched and squeezed by gravity, slowed by speed, and perhaps one day bent into loops by the strange physics of the early universe. We are only beginning to understand its secrets. Each new discovery brings us closer to unlocking the ultimate mysteries of existence. Which of these astonishing facts about time travel in space amazed you the most? Perhaps it's the realization that astronauts return to Earth ever so slightly younger than when they left. Maybe it's the idea that black holes can freeze time at their edges, or that GPS satellites must constantly correct for the warping of time just to keep your phone on track. Or perhaps it's the wild possibility that wormholes and cosmic strings could one day open the door to journeys through time itself. Whatever your favorite, one thing is clear. Time travel is not just a dream of science fiction. It is a real, measurable, and sometimes everyday phenomenon in the vast expanse of space. As we continue to explore the universe, who knows what other secrets time will reveal? The future is out there, waiting to be discovered. So keep looking up, keep asking questions, and remember, the journey through time is just beginning. The universe is vast, mysterious, and full of wonders beyond imagination. And as we travel together, second by second, we are all explorers on the greatest adventure of all, through time and space itself.